Hello and welcome back to our third video in our series on section 4.4 from our calculus text. And so this graph problem, this is the same graph that we looked at in an example from section 4.3, but this time we're going to be asking different questions about it. But we want to keep in mind that once again, we are being asked about, we're being told something about the graph of the derivative, and we're being asked questions about the function that we're not looking at. So we want to keep in mind the relationship between concave up, concave down, and the behavior of the derivative of the function. So our first question is, on what intervals is the function that we're not seeing concave up? And so we want to remember that concave up means that the derivative is increasing. And so this question is really asking, where is the graph that we're looking at increasing? And so we can see that the graph seems to start increasing right about here and goes till maybe right about here. So f prime is increasing on this interval. And so roughly speaking, so we say that f is concave up, and I use CUP as an abbreviation for concave up. So f is concave up when f prime is increasing. And so that, in this case, is going to be on roughly, say, -3.5 to about 1.5. And then it starts increasing right about here and then onward. And so this is going to be about 5.2 onward. Change the color here to answer question 2. On what intervals is the function concave down? And so we want to remember that f is concave down when the derivative is decreasing. And so while this was our answer to question 1, question 2, f is concave down, and I use CDN as an abbreviation for concave down, when f prime is decreasing. So let's think about that. So that's going to be this interval and this interval right here. And so that's going to be on roughly -infinity to -3.5 and approximately 1.5 to maybe about 5.2. And then finally, at what values does x have an inflection point? Well, that's a change in concavity. And so f prime goes from increasing to decreasing or decreasing to increasing. So anytime there's a switch in the direction of f prime, we're going to get an inflection point. And so that is going to occur right here and right here and then right here. So f has inflection points when f prime changes from increasing to decreasing or decreasing to increasing. And so that's going to occur when x is about -3.5, 1.5, and 5.2. And we're okay with just, pretty decent approximations. We could agree, we could have slight disagreements about what those values are, but as long as we're in the neighborhood of these numbers, I think that's perfectly fine in this case.